Section 1, we're going to look at analyzing categorical data, and it might be helpful to know what categorical data is. So we can separate data into two categories, either categorical or quantitative. So quantitative is something that's a number, but not all numbers are quantitative. It's something that is either a count or a measurement. So like shoe size, height, amount of money you make or spend, all of those are quantitative. Something like your phone number or your social security number, those things, even though they're numbers, are not quantitative because they're not counting or measuring something, they're just identifiers. Okay, so here we have some data. Preferred communication would be a categorical variable, and then we have our data values, which is what each person selected as their answer. Ways that we can organize data. None of this is going to be like new or very different for you. So we can do a frequency table. We can have a table that has a count. We can do relative frequency, which would just be percentages. We can also have proportions. Okay, so just pay attention to kind of what the question is asking for. Count, proportion is just a decimal, and then percent would be take that decimal and turn it into a percent. Okay. To display categorical data, we can use bar graphs. Okay, so we can take our counts or our relative frequencies, or percents, whatever one we put on the y-axis, and then we can make bar graphs. We can also do pie charts, okay, where we have each percent of the circle. Just be careful on the pie charts. Your percentages have to add up to 100%. So if they don't, sometimes we can add in like an other category, but you also have to make sure that all those data are coming from the same whole when we make a pie chart. Okay. So bar graphs, kind of plain, okay? And so sometimes you will see people make them with pictures or sort of 3D effects on them to make them like look cool. But in statistics, we don't want to do that because those graphs can be misleading. So here's an example. We have the number of made shots and number of assists for Kobe Bryant. He had 5 assists per game and 10 made shots per game. But the way those basketballs are drawn, it makes it look like this one is a lot more than double that one. Okay, so we don't want to use pictures like this. The other thing is we want to have our y-axis start at 0. Okay, so if we look at this, like Chevy is clearly the best, and then it goes down like Toyota, this kind of looks like a sizable gap, and then this Nissan group, like that looks like a huge gap. But if you look over here at these percentages, it goes from 95 to 98. Okay, so the Nissan, it's really only like a 3% difference. So if we took this same graph and put it on a 0 to 100 scale, the difference doesn't look that large. Okay, so over here, Chevy looks great. Over here, they all look great. Okay, so all y-axis should start at 0 generally, because especially when we're dealing with percents, because otherwise the graphic can be misleading. Okay, if we have two variables combined, we can use something that's called a two-way table. Okay, so we asked a bunch of people 2 questions. Are you in the environmental club? And do you use a snowmobile? Okay, and so we put those together in a two-way table. And so I'm looking for where those things intersect. Like no and never was 445 people. Yes and never was 212 people. And sometimes they add the totals. Sometimes you might need to add the totals yourself. But this is called a two-way table. And for two-way tables, now it organizes the information really nice where we can answer all kinds of questions about our data. There's going to be names for these different kinds of things. Don't get caught up in the name. The name is really not that important. It's more, can you answer this question? Okay, so what % of people in the sample are not environmental club members? We're just looking for all the no's, 1221, out of the total of 1526. All right, so that is equal to 0.8 or 80%. There are no like hard and fast rules in AP Stats for rounding, so just kind of whatever feels good to you. I don't know, 2 decimal places, 3 decimal places, depending on the numbers. There's not really a hard and fast rule there. Okay. Second kind is called a joint relative frequency. Again, the name is not really that important. These are and questions. So what percent of people are both environmental club members and own snowmobiles? So we're looking for the box where those two intersect. So it would be 16 out of our total, and that's roughly 1%. Okay. So joint is our and questions where we're looking for both variables. And then the last one is called a conditional relative frequency. This is where we're kind of breaking down and just looking at a small subset. So what percent of environmental club members are snowmobile owners? So now I'm only looking at the people that are in the environmental club instead of my whole total of 1526. All right, and then we also have what's called a conditional distribution, and that's where we just list out all of the percentages or relative frequencies for each answer. So if I want the conditional distribution of snowmobile use among environmental club members, I'm looking at all the members and what are the 3 possibilities: never, renter, or owner, and I'm going to find all 3 of those percentages. That is called a conditional distribution. Okay, so like we could do the same thing for not environmental club members. Okay. Things that we want to make sure we do or avoid. We want to make sure we use relative frequencies, so percents or proportions instead of counts, just because it makes it easier to compare. And then we also want to make sure that we include like anything that we're writing in our answer, that we're including those percentages instead of saying something like more club members never use snowmobiles. That's referring to a count, but we're actually looking at a percentage. So we want to say a greater percentage of club members never use snowmobiles. So that language, when we're talking about like FRQs and they get picky, that language is going to be super important. Okay. 2 other things that we can look at to try and see a relationship between 2 categorical variables. One is a side-by-side bar graph. Okay, so here we still have our environmental club and snowmobile use. All right, and we did bars for the non-members and bars for the yes members. The other way we can do this is called a segmented bar graph, and that's where we stack them on top of each other. Okay, so same data, all right, but here's my no's, the 3 categories, my yeses, the 3 categories. Both of these are good. There's no like one or the other. It's typically whatever the problem asks you to make. When we talk about these graphs, generally, it's way more important for you to be able to analyze and look at them than to be able to create them. Maybe a quick sketch, but usually you're going to be given the graph and asked to answer some questions about it versus just making a graph, which is, kind of more basic. All right. Now, what we're using these for is to determine if there is an association between the 2 variables. Okay, so is there some sort of relationship between being in the environmental club and your snowmobile use? Okay, if these 2 graphs look different, then we would say, yes, there is an association. Okay, so the no's have much different percentages than the yes for the environmental club, so we would say there is an association. If one does not affect the other, then we say there's no association, and in that case, the percentages would be roughly equal. Now, in this picture, they are exactly the same. That won't always be the case, but if they're really close, then we would say there is no association between the variables. Okay, and then most important rule of statistics: association does not necessarily imply causation. All right, you may have heard this as correlation does not equal causation. Okay, so be very, very careful. Say that there is an association between environmental club and snowmobile use, not that being in the environmental club causes something related to snowmobile use. All right, very, very important. We always want to refer to an association between variables and not try to talk about causation unless we have an experiment with randomly assigned treatments. All right, and that's it for 1.1.